I am here with the free response one, and along with solving the free response question, I'll be providing a few important tips and tricks on how to generally solve a free response question one instead of particularly pertaining to the question that we have. So, and again, I'd like to reiterate that FRQ1 is the easiest free response question. So, I want you to score full credit in this part. Let's move ahead. Now, this is how your sample FRQ might look like. You'll either have a graph or a table with particular inputs and their corresponding outputs. Over here, we have a function f on the domain negative 3.5 to 3.5, and we have another function g of x, which is 2.916 times 0.7 to the power x. And remember, you have the graphing calculator in this part. Now question A says the function h is defined by h of x is equal to g of f of x, which is a composite function. Find the value of h of 3 as a decimal approximation or indicate that it is not defined. Now when I say h of 3, I put x as 3 instead of x in the entire equation. So using this relation that I have, if I have h of 3, then my h of 3 will be equal to g of f of 3. But what is f of 3? Well, if you look at the graph right here, you'll see that here is the point where we have x3 and the corresponding y coordinate is 1. So f of 3 is 1. Since f of 3 is 1, we are asked to find g of 1. Now, do not forget that you have the graphing calculator. So do not sit to evaluate 2.916 times 0.7 to the power 1. Quickly pull out the calculator, plug in the numbers, and get the value. I just did it now, and my answer is 2.041. I think that is correct. If you put it up correct to 2 or 3 decimal places or even 2, it is completely fine, and you'll get 1 credit for your value. The second question is find all values of x for which f of x is equal to 1, or indicate that there are no such values. Now, do not confuse between input being 1 and an output being 1. Over here, they ask you the values of x for which the output is 1. So here, I'll clear the pen marking over here. We have f of 1, the output 1 right here, and you see the line intersects 3 places. One is right here at -3, one at here at 0, and one at 3. So all values of x would include -3, 0, and 3. And that's it, my friends. That's how simple a FRQ is. Let's move on to the next part, which is the B one. Find all values of x as decimal approximations for which g of x is equal to 2 or indicate that there are no such values. Now, we know that the function g of x is a very complicated function. It is not complicated, but it has decimal places. I think it was 2.916 times 0.7 to the power x. And if you want this to be 2, then you'll have to do a bunch of calculations and logarithms first to get x in the base and then use the calculator again and stuff like that. So whenever you look at this, understand that you will have to use a calculator immediately. I'll move to the calculator and keep the question in mind or note it down somewhere. Now, once you make it to your calculator, I'm going to show you how to use it. I'll be using a T184 Plus since I think most of the people prefer this one. Now, you have to find out a output value which is 2, right? So first of all, we'll go to stat plot y, the top left button right here, and you'll in y1 you'll input your g of x, which is 2.916 times 0.7 to the power x, and in y2 you'll write 2 since we are interested in finding the output value 2. So one of the graphs will be of y equal to 2 and the other one will be our g of x, and then I ask it to graph, and then you'll see that our graph somewhere intersects right here at 2 at y equal to 2, but we do not know the exact value, and if we have time then we should not lose credit. So I'll press second and go to calculate right here, In the fifth option, I have intersect. I'll go into intersect, enter. Now it will ask me to guess the values. So keep it close to 2. I'll enter this one. I think that is correct. I'll enter this one. Guess, doesn't matter, just enter. And it gives you the intersection, which is 1.0571688 at y equal to 2. Now I'll remember this value and write it down. X is equal to 1.057 is the only value for which my output is 2. That'll be it. Now there are two ways you could approach the second question. It says determine the end behavior of G as x increases without bound. Express your answer using the limit notation. Now since we already had a graph in part 1, you don't need to input the value. So just press the trace button and keep tracing the graph by pressing right, 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 right. And the end behavior become very clear and simple. But if you want to approach it mathematically, then if we write down the function of g of x, which is 2.916 times 0.7 to the power x, if you take x to be any huge large number, if x were to be 100,000, if x were to be 100,000, then what would your answer be? Well, you know that this value right here is a decimal place which is less than 1 is being raised to the power 1000, which will tend to 0. It will not become 0. Remember, if you multiply 0.7 times 0.7 times 0.7 100,000 times, it will not become 0, but it will rather become a very, very, very tiny number, which is multiplied by yet another tiny number. 2.916 compared to a decimal place with 10 digits is small. So as x increases arbitrarily, you realize that your function decreases arbitrarily, but it does not become zero. It does not become zero, but it rather approaches zero. So the best way to write this would be limit as x approaches infinity of g of x is 0. And if you would like to add an extra sentence, if you're not sure about this, you could write as x increases without bound, the output values of g get arbitrarily close to 0. You could write that sentence as well. Along with this one, you need to write this one. If you don't write this one, it's your choice, the sentence that I just said. Okay, I hope that was very clear. Let's move on to the third and final part. Now the last part is determine if f has an inverse function. Now you will get this type of question, and I want you to remember one thing, which is the horizontal line test. It means that if you draw a horizontal line in any part of your graph, I'll choose another color. If you draw a horizontal line on any part of your graph, then if it intersects at only one point, then your function is invertible. If any horizontal line intersects the graph at more than 2 points, it intersects at 2 points here, 2 points here, 3 points here, in fact. So, 3 points here as well. So, if your horizontal line at any point intersects more than 1 point in a function, then it is not invertible. Here you can clearly see most of the horizontal lines pass through 2 to 3 points. So, you'll clearly state that no, it does not have an inverse function. Now, what would your reason be? Your reason would be that there are output values of f that are not mapped from unique input values. And if you're given a table with values, and if you see that two or more input values are mapped to the same output value, the function will not be invertible. For instance, if I have x as 0, 1, 2, and have y as -1, 2, and -1. If you have something like this in your question and they ask you whether it is invertible or not, then you say no. The reason is that two unique input values map to the same output value, and when you invert your function, this input value will map to two output values. And we know from the definition of a function that one input cannot map to two output values. So while the function as such is defined, two input values can have the same output, but if you want to invert them, then each output should map to a unique output. So your reason would be that there are output values, I'll write it in short, there are output values of f that are not that are not what that are not mapped from unique input. Excuse my bad handwriting. I'm not familiar with this kind of digital pen. And yeah, that should be it. That's how you will answer your FRQ1. And again, it is the easiest part. I hope everything was clear. If there is any doubt, any problem, any more practice that you need, mention me in the comments below. I'll help you out for sure. Thank you. Have a good day.